Part 2 of this lesson talks about how to solve fourth power equations when we're actually solving for x. Remember, when we're solving equations with exponents, we really like them set equal to 0. So before you try to solve it by any type of factoring, make sure it's set equal to 0. So example 6 is solve 18x to the fourth minus 21x squared plus 3 equals 0. So it is already set equal to 0, so it is ready to be factored. Remember, the very first part of factoring is that making sure that you can't take anything out by distributive property. And this one we can. We can factor a 3 out of 18, negative 21, and 3. 3 times what is 18x to the fourth? Well, that would be 6x to the fourth minus 7x squared. And 3 times what is 3? Well, that would be 1 equals 0. So we factor a 3 out. And then, after we factor the 3 out, we look to see if we can do a binomial pair. And fourth power equations, when there are 3 terms or 2 terms, works well with this because it's just like binomial pairs that we've done with quadratic equations, but instead of separating it in x and x, we can separate it with x squared and x squared because x squared times x squared is x to the fourth. Now, this one also had a 6 with it, so we have to figure out how to separate 6x to the fourth. There's 2 ways to separate 6x to the fourth. There's 3x and 3x squared and 2x squared. But there's also 6x squared and x squared. And if you try 3x squared and 2x squared, then you got to figure out 2 numbers that multiply to be 1, but then add together to be negative 7x squared. And the only 2 numbers that multiply together to be 1 would be 1 and 1. They both would have to be negative in order to multiply to be positive 1, but add to be negative 7. But notice it doesn't work out. You get negative 2x squared and negative 3x squared, and that's not going to work because that adds up to negative 7x squared. So 2x squared and 3x squared actually doesn't work. We should use 6x squared and x squared. So I'll place in x squared and 6x squared. And then when you do your horseshoe check, notice that we have negative 6x squared and negative 1x squared, and that does add up to the negative 7x squared. That's my middle term. And then I would set each part equal to 0. Now that actually still includes what you factored out. You would set 3 equal to 0. Anything factored out, you would set equal to 0. But since 3 equals 0 doesn't make sense, we would just ignore that. So I'm solving x squared minus 1 equal to 0 and 6x squared minus 1 equal to 0. And to solve these equations, since it's just something squared and then another number, I can solve these with square roots. So I can add 1 to both sides. So that would give me x squared equals 1. And then I would do a square root of both sides. And remember, as soon as you square root, and the reason we're square rooting, because square rooting cancels out being squared, as soon as you square root in an equation, that's where you have to include plus or minus. Because there are 2 solutions for the square root of 1. There's positive 1, because 1 times 1 is 1. But there's also negative 1, because negative 1 times negative 1 also equals 1. So that half of this problem has 2 solutions, positive 1 and negative 1. We're going to solve 6x squared minus 1 equal to 0 by adding 1 to both sides. So that would be 6x squared equals 1. Then divide by 6. Don't get too antsy about trying to square root just yet. Well, let's cancel that 6 out first. So that would give me x squared equal to 1/6. And then we would do a square root of both sides. And when you square root a fraction, it's just the square root of the top over the square root of the bottom. So that would be x equals plus or minus. The square root of 1 is just 1. We can't take the square root of 6 because it is not a perfect square, so it's just the square root of 6. But then there's an issue because we shouldn't leave a square root on the bottom of a fraction. So we have to rationalize the denominator by taking it times the square root of 6 over the square root of 6, which would give me an answer of the square root of 6 over positive 6. So there are actually 4 solutions to this. There's the plus or minus 1 that we got at the start, and then there's x could also equal plus or minus the square root of 6 over 6. So 4 different solutions to this. So let's try another one. 4x to the fourth minus 8x squared plus 3 equal to 0. This one is ready to be factored because it is already set equal to 0. And we can't do a distributive property factoring because nothing goes into 4, 8, or negative 3, or positive 3, excuse me. So we can't do a distributive property factoring. So we're just ready for a binomial pair. So I could split up 4x to the fourth in two different ways. It could be 2x squared and 2x squared, or it could be 4x squared and 1x squared. Let's try 2x squared and 2x squared. And factors of positive 3 that add up to negative 8, since I'm trying to multiply to be a positive number but add to be a negative, I need two negatives. And if we do negative 3 and negative 1, that would give me inside terms of negative 6x squared and outsides of negative 2x squared, and that does add up to negative 8x squared. So we do have it factored correctly. So then set each part equal to 0. And we solve for x. So on the first one, I'll add 3 to both sides. So 2x squared equals 3, and then divide by 2. So that gives me x squared equals 3 halves. And then do a square root of both sides. So that would give me x equal to positive or negative square root of 3 over the square root of 2. Because that's how you take the square root of a fraction, just the square root of the top over the square root of the bottom. I can't leave a square root on the bottom of the fraction, so I need to rationalize the denominator by taking it times the square root of 2 over the square root of 2. And that would give me the square root of 6, because 3 times 2 is 6, over just 2. It's not the square root of 2, because the square root of 2 times the square root of 2 is the square root of 4, and the square root of 4 is just 2. So the first half of our answers are plus or minus square root of 6 over 2. Then we do the same thing on the other one. So we'll add 1 to both sides. So that's 2x squared equals 1. Divide by 2 gives me x squared equal to half. And then do a square root on that one. So x will equal plus or minus. The square root of 1 is just 1, so there's no square root on the top right now. But then the square root of 2 is still just the square root of 2, which means I do have to rationalize the denominator. Taking it times the square root of 2 over the square root of 2, which means on this part, x is going to equal plus or minus. So I've got 1 times 2, and 1 times 2 is, or square root of 2 is just the square root of 2. And the square root of 2 times the square root of 2 we already said is 2. So this part is plus or minus square root of 2 over 2. And those are the answers there. So let's try 6b. This one's already to be factored because it is set equal to 0 already. So we can take a 2 out of this one. So 2 times what is 8x to the fourth? Well, that would be 4x to the fourth. 2 times what is 10x squared? Well, that would be 5x squared. And 2 times what is negative 12? Well, that would be negative 6. And then we go to a binomial pair. And again, we can split up 4x to the fourth as 2x squared and 2x squared, or 4x squared and x squared. And for the sake of time, I'll go ahead and tell you it's 4x squared and x squared. And we need factors of negative 6 that will add up to equal positive 5. So factors of negative 6 that adds up to equal to positive 5, well, that would be, let's see here. If I put a negative 3 here and a positive 2 here, that would give me insides of negative 3x squared and outsides of positive 8x squared, and that does add up to 5x squared, as it should have been squared up there already. And so we do have it factored correctly. And then we would set each part equal to 0, including what we factored out, even though in this case it doesn't make sense. So I'm just going to ignore that. So it's going to be 4x squared minus 3 equals 0, and x squared plus 2 equal to 0. And then I solve both of those for x, so I would add 3 to both sides. So 4x squared equals 3, divide by 4. That would give me x squared equals 3/4. And then do a square root of both sides. So x will equal, don't forget your plus or minus, square root of 3 is just the square root of 3. Square root of 4 is just 2. So actually I don't have to rationalize this one because the 4 was already a perfect square, and when I took the square root of 4, it just gives me a 2. On the other one, I subtract 2 from both sides, so I get x squared equals negative 2. Then I do a square root on this one. So that gives me x equals plus or minus the square root of negative 2, but I have the square root of a negative number, and what's that mean? That means there might be an I coming back into play in this lesson. Square root of negative 2 is the same as I times the square root of 2, so don't leave a negative square root in your answer, use I instead. This is the last one. This is not a fourth power, it's a third power. It's x to the third minus 64 equal to 0. So this is similar to what we had on part 1 of this lesson, the part 1 video, where we have perfect cube factoring. So perfect cube factoring is when we have the small set of parentheses and the large set, just like in part 1. And the cube root of x cubed is x. The cube root of negative 64 is negative 4. And then I use that set of parentheses to help create the next set. Because remember, the first term is going to be squared. It'll be the first term in the second set, so that'll be x squared. The last term is squared, and it will be the last term in the big set, so 4 squared is 16. And the middle term has that different sign and just the two terms multiplied together. So x times 4 is 4x. Remember, it's a different sign because if this simplifies to just x cubed minus 64, lots of things have to cancel out. And then just like we did a while ago, we're going to set each set of parentheses equal to 0. So x minus 4 equal to 0, and x squared plus 4x plus 16 equal to 0. And x minus 4 equal to 0 is simple enough to solve. We just add 4 to both sides. So that would be x equal to 4. But what about x squared plus 4x plus 16 equal to 0? Well, it might be tempting to try to factor that and do x and x, but the problem is you're not going to find factors of 16 that add up to 4x. It's just not possible. As a matter of fact, on these perfect cube factoring, the second part is not going to be factorable. So don't even try to do it. Don't waste your time. It's not going to be factorable. So if it's not factorable, then how can we solve for x with that second part? Well, we have our quadratic formula. So the quadratic formula is going to come back this lesson as well. So review your quadratic formula. Remember, it's negative b plus or minus the square root of b squared minus 4ac all over 2a. So our b value is 4, so that would make it negative 4 plus or minus the square root of 4 squared minus, a lot of 4's here, minus another 4, times a. The a value is the first term, and that's a 1, times the c. The c value is the 16, all over 2 times 1. And then we simplify underneath the radical. 4 squared is 16, and negative 4 times 1 times 16 is negative 64, all over 2. That's negative 4 plus or minus the square root of negative 48 over 2. And square root of negative 48 seems awfully large, so let's simplify that. We know we're going to have to use I because it's a negative. And the largest perfect square that goes into 48 is 16, goes in there 3 times, meaning that this is going to be 4i square root of 3. So I'm going to replace that square root of negative 48 with 4i square root of 3. And then I see I have negative 4, I've got negative or positive 4, and then I've got a 2 there. I can divide all of those by 2. So I will do that. Means my answer will be negative 2 plus or minus 2i square root of 3 over 1. And I don't need that over 1, so I'll just erase that. So here are my second answers, negative 2 plus or minus 2i square root of 3, along with the answer that I got way back here of just 4.